You point your phone at a QR code, nothing happens. You move closer, still nothing. You tilt your phone, adjust the angle, move to better lighting, and it finally works. But why did it struggle in the first place? And more importantly, how does a damaged, crumpled, or partially covered QR code still manage to work at all? Because here's the thing. That little black and white square is doing something incredibly sophisticated in the fraction of a second your camera looks at it. And most people have no idea. Stick around, because once you understand what's actually happening inside that grid, you'll never be frustrated by a slow scan again. QR codes are everywhere. On your coffee cup, on highway billboards, on your doctor's appointment reminder, on the screen at a concert. We scan them without thinking, without questioning, without realizing that what looks like a random mess of black and white pixels is actually one of the most cleverly engineered data systems ever built for everyday use. And the funny thing is, most people think QR codes are a recent invention, something that exploded during the pandemic when restaurants replaced their menus with them. But the truth? This technology is over 30 years old. And its origin story has nothing to do with smartphones, Silicon Valley, or the internet. It starts in a factory with cars and a problem that nobody had figured out how to solve until one engineer decided to look at it completely differently. It's 1994, Japan, a massive Toyota manufacturing plant humming with activity, thousands of car parts moving through assembly lines every single hour. Back then, factories used standard barcodes to track everything. You've seen them, those vertical black lines on every product you buy. They worked fine for simple tasks, but inside a car factory, simple wasn't enough. A single car has over 30,000 individual parts. Each one needs to be tracked, sorted, and assembled in the right order. And a standard barcode? It could only hold around 20 characters of information. That meant workers had to scan multiple barcodes on a single part just to get the full picture. It was slow, it was inefficient, and it was becoming a serious bottleneck. That's when a young engineer named Masahiro Hara, working at Denso Wave, a subsidiary of Toyota, decided enough was enough. He didn't just want a better barcode, he wanted something completely different. Something that could store hundreds of times more data, something that could be read instantly from any angle, and something that could still work, even if it got dirty, scratched, or partially destroyed on the factory floor. His inspiration came from an unexpected place, the ancient Japanese board game, Go. Looking at the game's grid of black and white stones, Hara realized that information didn't have to flow in just one direction. Instead of lines, you could use a two-dimensional grid, encoding data both horizontally and vertically at the same time. After 2 years of development, in 1994, the QR code was born. QR standing for quick response, because the goal was simple. Scan it, get the data, move on. But here's the twist. Denso Wave made a decision that would change everything. They released the QR code patent as open and free for anyone to use. No licensing fees, no restrictions. Anyone in the world could use this technology at zero cost. For years, it stayed quietly in factories and logistics warehouses. Then came the smartphone, and everything changed. So what exactly is happening in that fraction of a second when your camera reads a QR code? Let's break it down, because this is where it gets genuinely fascinating. First, your camera needs to find the code. And this is where those 3 large squares in the corners come in. You've probably noticed them. They look like square targets sitting in 3 corners of every QR code. These are called finder patterns, and their entire job is to tell your camera, here I am, this is where I start, and this is my orientation. This is exactly why a QR code can be scanned upside down, sideways, or at a weird angle. Those 3 squares give the scanner all the orientation information it needs in an instant. Once your camera locks onto those finder patterns, it starts measuring the grid. Tiny alternating black and white lines running between the corners act like a ruler, telling the scanner exactly how large the grid is and how many data squares it contains. Then comes the actual reading. every small black or white square inside the grid represents a 1 or a 0. Black equals 1, white equals 0. Together, these binary patterns spell out the encoded information, whether that's a web address, a payment link, a Wi-Fi password, or plain text. A standard QR code can hold up to 4,296 characters of text. That's roughly 3 full pages of a novel compressed into a square the size of a postage stamp. But here's the part that most people never think about. What happens when the code is damaged? Say the QR code on a product got wet, or someone drew on it, or it's been sitting in the sun for months, and parts of it have faded. This is where error correction comes in, and it's honestly one of the most elegant engineering decisions in the entire system. When a Q code is generated, it doesn't just store your data once, it stores it with built-in redundancy, meaning the same information is encoded multiple times across different parts of the grid. So if up to 30% of the code is completely destroyed, torn, covered, smudged, your scanner can still reconstruct the full data from what remains. Think about that. Nearly a third of the code can be missing, and it still works. That's not an accident. That's deliberate, careful engineering designed for the real world, where things get dirty, damaged, and worn. Now here's where most people's understanding of QR codes stops. But the story doesn't end there, because there are actually 2 completely different types of QR codes, and most people have no idea the second type even exists. The first type is what you're probably familiar with, a static QR code. The information is permanently baked into the pattern of the grid. Once it's printed, it's fixed forever. The URL it points to, the text it contains, it can never change. If you want to update the information, you have to generate and print an entirely new code. But the second type, a dynamic QR code, works completely differently. The code itself doesn't contain your final destination. Instead, it contains a short link that points to a server, and that server decides where to send you. This means the same printed QR code on a restaurant menu can point to a summer menu today, a winter menu in December, and a special holiday menu on Christmas Eve, without ever reprinting a single thing. Event organizers use dynamic QR codes for tickets that can be updated in real time. Businesses use them to track exactly how many people scan their code, when, and from where. A single QR code becomes a living, breathing data tool, not just a static gateway. And here's the question we're thinking about. Next time you scan a QR code and get redirected somewhere unexpected, ask yourself, is this code static or dynamic? Because you genuinely have no way of knowing just by looking at it. So here's a question for the comments. What's the strangest or most unexpected place you've ever seen a QR code? A gravestone? A piece of fruit? Let me know below. Some of your answers might just end up in a future video. If you learned something today, hit that like button. Genuinely helps this channel grow. Subscribe if you want more stories like this one. And I'll see you in the next one.